All right. So quickly, guess a number between 1 and 20. 1 and 20 is also included. If you guess correctly, you get to add $35 to your bank account. Let's see what number this was. And the lucky number was 5. No one chose 5. All right, one person chose 5. All right, so if you chose it, but I missed it, add $35 to your bank account. And let's move on. All right, so this is what you're going to need last week notes for. You don't have to draw this right now, right? You can draw this after. I want you to concentrate on the answers. So we have a mysterious substance, right, in the test tube here. In our first test, we are going to add some sodium hydroxide solution. When we did that, we got two things. At first, we got a white precipitate. And afterwards, we decided to add plenty, like excess sodium hydroxide. And when we did that, the white precipitate disappeared, meaning that the white precipitate became soluble. And of course, when it dissolves, it could no longer be seen. What could possibly be in that test tube? Go back in the notes and try to guess what could be inside that test tube. The answer to this question, it could be any one of these three things. It could be Al 3 plus, Zn 2 plus, or lead 2 plus. Go back in your notes and you will see all three of these ions, all three of them give you the exact same result. It's almost like you can't tell definitely which one it is. It's like you have three suspects that did a crime, but somebody did a crime and you have three suspects because the three of them give the same result. But we need to find the true criminal. Everyone who got it wrong, please let me know. Go back in your notes and confirm if you saw Al, Zn, and lead. Make sure you physically see it. All right. So we say, because the aim of this question, we're trying to identify, like to confirm which one it is. Telling somebody it's aluminum, zinc, or lead is not good enough. We need only one. We need to confirm exactly which one it is. So we say, all right, we can't tell the difference between Al, zinc, and lead. So we decide to do another test. We said, all right, we're going to take the same test tube, our next test tube with the same unknown element in it, the unknown substance, sorry, and we are going to add ammonium hydroxide. So we add the ammonium hydroxide and we also get a white precipitate, and also the precipitate dissolves to become colorless. What could it be using this new test? Remember, this test is a white precipitate and it dissolves. This one also dissolves to become what? Colorless. This one here, when you use the ammonium hydroxide, the only thing it could be is zinc 2 plus. For those who got it wrong, you see that? There's only one test for the ammonium hydroxide that will give you a white precipitate, and when you add excess, it will dissolve and turn into a colorless solution. Some of you are reading it wrong. It have one where the precipitate does not dissolve, but in this particular one, it does dissolve. Confirm it with me, guys. With those who got it wrong, make sure you see active. Someone gave us a mysterious compound to try to identify like what it was. When we used the first test, we were unable to narrow it down to one person. So we said, okay, we would use a different test. And the next test, the second test, we were able to narrow it down to one person. So the customer was satisfied, or our boss was satisfied with our work. Now look how this question is going to change slightly. It's such a subtle change. The slide is going to change now. Almost everything looks the same. So you might say, "Sir, going crazy. He's asking me the same question." All right. Let's look at the first one now. So the first one, we're adding sodium hydroxide again. We get a white precipitate and it dissolves to become a colorless solution. We know the answer for this one already. It could be aluminum, lead, or zinc. It could be Al3 plus, lead 2 plus, or zinc 2 plus. The person is not going to pay us because we didn't narrow it down. We didn't figure out which element it was. He doesn't want 3 elements. He wants us to narrow it down to 1 element. So we say, all right, we're going to use our next test, the one with the sodium hydroxide. But this time, we get a white precipitate, but this time, the precipitate is not soluble. It's an insoluble precipitate. So the precipitate does not disappear. It remains there, no matter how much ammonium hydroxide we add. What could it be? Aisha, check it back. Right. All right. When you do this test, you can only narrow it down to aluminum or lead. Look at that. Look at your table, sorry. You will see that white precipitate, and in excess, it's insoluble. For those who got it wrong, check it back. Do you think the person is going to pay us? Remember, he paid us to identify what the element, well, what the substance was. Well, he's paying us to identify what cation exists inside that solution. Are we going to get paid? Yes or no? But at least we made some progress. When we did the first test, it had 3 suspects. So we say, all right, he's definitely not going to pay us. So we did the second test and we were able to narrow it down to 2 suspects, but we're still not going to get paid. So we say, all right, obviously to determine whether it's aluminum or lead, we're going to have to do a 3rd test. And only when we do that 3rd test and narrow it down to 1 ion, then we will get paid. So let's see what's going to happen now. So it's between aluminum and lead. Okay, so let's move to the next slide now. Okay, just pay attention for the time being. So this is the last test to tell the difference between lead and aluminum ions. The final test is now we have to take potassium iodide. And if we add potassium iodide and we get a bright yellow precipitate, then it's lead. If we add potassium iodide and we get no precipitate, then it's aluminum. So you have to go through those 3 tests now to kind of narrow it down. I know some of you will say that are probably thinking, well, why we just didn't jump to the last test first? It doesn't work like that. There's a sequence you have to go through to eliminate ions in a scientific matter, in a mathematical way. You just don't jump to the last test first. You have to kind of go through the procedure to systematically eliminate the ions one by one by one. I need you to take down everything on this slide because everything else, you already have it in your tables. This is the only one that's missing right now. Move on. Let's see what the next slide is about. All right, so before we move on, right? So remember, you're selling something on the street, you have a little, you upgrade to a little cart now because you're making more money. A mean police officer tells you that you cannot sell there anymore, right? She forces a bribe out of you. Choose one of the colors. The colors will determine how much bribe you pay to the police officer. So in this case, you're going to have to minus money. So choose a color, red, blue, or green. Let's hope you get a very small number this time. Take your time. Let's see which one you choose. All right. So the best one was the green. So you might, depending on the color you pick, minus that amount of money, right? Because it's a bribe, right? So you're paying it out of your money, right? Don't worry, it's only a small bribe. But I bet you'll be back there tomorrow and the day after and every other day after. All right. Great. So let's move on. Right, so I think everyone remembers this. You don't have to take this down. You'll remember this thing called the metal reactivity series. Remember, potassium is what? The most reactive one, while platinum and gold, right? These two here are the least reactive metals, okay? And I'm going to make you take down this. This is just a reminder of the reactivity series of metals. I think this is going to play a part in a little while, right? So that's why I'm refreshing your memory. All right. So yeah, I know this looks scary. This could take a little while, right? Now we're going to test for anions. Anions are the ones that have what? A negative charge. So bear with me here. I will give you time after to take it down. You just pay attention for the time being. So I think everyone knows about these anions. CO3 2 minus, right? That is what? Carbonate. And if it have a H, well, that's hydrogen carbonate. What we are doing here is something called the effect of heat. Whenever you add heat to a compound, it usually breaks down the compound. It is called a thermal decomposition. Thermal decomposition, let me just put this here. Thermal decomposition. I know that's a fancy term, it may seem scary, but thermal decomposition just means you're going to add heat to something, and when you add heat to it, it will break it down into smaller parts. Because that is what decompose means. When something decomposes, it's breaking down into smaller parts. So anytime you have CO3 2 minus or HCO3 2 minus, right? You get carbon dioxide being produced. So if you take either one of these and you add heat to it, you're going to see carbon dioxide being produced. Now, if they ask you for the ionic equation, you start off with this. CO3 2 minus, well, usually anything that has carbonate, right? We take any solid form of it, right? And we add heat. And when you add heat, you get O2 minus plus carbon dioxide. Just to clear up a little misconception here. Does this O mean oxygen gas? Does that O mean oxygen gas? Look at how it's written. The answer is no, right? Because oxygen gas is what? O2, and it's neutral. This O2 minus means this oxygen is combined with something, right? It is combined with something. That's why it has a charge of 2 minus. But remember that on the This over here is the ionic equation. Let me give you an example of the full equation. So I'm going to put a little star here. An example of this full equation is this one here. You're going to take calcium carbonate, a type of carbonate. This will be a small tree, by the way. Sorry about that. And when you add heat to that, you're going to get what? Calcium oxide. Look at it. You notice the oxide is bonded to the calcium. So the oxygen has a charge of what? 2-, which is this 2- over here. But you get neutral carbon dioxide. This is supposed to be a small 2. Once again, I apologize. I want everyone to take down the first row, right? And if possible, you think you could squeeze the real equation underneath here, right? So you can see the ionic equation and the full equation side by side, right? Because you don't know which one the examiner is going to ask you for, whether he wants the ionic equation or the full equation. Okay? Let me know when you finish with the first line only, the first row. And oh, by the way, you have an example for the hydrogen carbonate here. Look at it. Calcium hydrogen carbonate. Squeeze this one underneath here too. So you have 3 things to write. So I'll put a little asterisk here too. Right, so carbonate or hydrogen carbonate, when you heat it, expect to detect carbon dioxide. And you all know how to detect carbon dioxide. You just bubble it through lime water. And if you get a milky white color, you know it's what? Carbon dioxide. Now, the other one is nitrates, but it's nitrates of potassium and sodium only. When you do that, well, when you heat that, you're going to get oxygen. And you all know how to test for oxygen. It is do what? Oxygen will relight a glowing splint, right? And this here is the ionic equation over here. So I'm going to put a dot, a real huge dot here. So that's the ionic nitrate. And when you heat that, you're going to get potassium nitrite, that is NO2 plus oxygen, right? So you see the full equation and the ionic equation fit one on top of each other. Because once again, you don't know which one the examiner is going to ask you for in the exam. Now, the next one is the heating of nitrates again, right? But Apollo tick this time. But remember, potassium and sodium are very high in the metal reactivity series. So potassium and sodium nitrite just behave a little bit different to everybody else. You see, from calcium go down in the metal reactivity series. If you have a nitrate version of them, you get 2 things when you heat it. You not only get oxygen, but you also get nitrogen dioxide. And this here is what? The ionic equation. And I have 2 equations over here. And you see, silver and magnesium are definitely below calcium, like it's calcium and below. But when you heat it, you will get 2 things: oxygen and nitrogen dioxide, right? So you know what to do, right? Take down the ionic equation, and I have 2 examples of the full equations. All right, so let's do the last one quickly, right? Now, this one is easy to mistake. SO3 2-, that anion. What's his name? Like how CO3 2- is carbonate NO3. Sorry, I made a small mistake, guys. I don't know if you all spotted this mistake, right? I don't know if you all spotted a mistake. This is supposed to be NO3 minus. This is supposed to be a small tree below here. NO3 minus. That is nitrate. My mistake, right? It's a little editing error there. So let's fix that first. And I think I have a question to answer. All right. So once again, I apologize for the error with the NO3 because nitrate, the charge is supposed to be minus. Right. So the question was asking, what's the name of SO32 minus? Like how CO32 minus is carbonate, NO3 minus is nitrate. What do we call SO32 minus? What's his name? I thought I would get Ranisa correct. I thought I would get you there. No, Joshua, you get catch. Right? It's a real simple, it's so close now. Right, Shakira, correct. One more person. What is SO32 minus? Right, it's sulfite, not sulfate, right? Sulfate is FSO4 2 minus. This is SO3 2 minus. That's sulfite. Okay? It's so easy to what? To mix up. Right? Right. So, but anyway, we're dealing with sulfite, not sulfate. And when you heat a type of sulfite, you get sulfur dioxide. That's the type of gas that's produced. And this here is the ionic equation to go with it. I apologize. I don't have an official example to go with it, right? But you have the ionic equation at the moment. Okay, so let me know when you finish with everything on the screen, and we're going to move to the next slide. All right. So now we're going to test for anions, not by heating them, but we're going to add a dilute acid. Now, the dilute acid is either going to be hydrochloric acid or nitric acid. This one here, I don't think it needs too much explanation. I think you all get the general idea. If it's carbonate or hydrogen carbonate, and you add any one of these acids, once again, you're going to get what? Carbon dioxide being what? Produced. Here we have the ionic equation, and here we have an example of the full equation, right? One example of it, and it's balanced already. And if you have sulfite and you add any one of these acids, you're going to get sulfur dioxide. You have what? The ionic equation, and you have an example of it as well. In both cases, I added hydrochloric acid. You're going to have a very similar reaction if you added, how you say, the nitric acid. Let me know when you're finished with both of them. Over here, what other tests? This one was dilute acid. Sorry, one person says it needs some more time. Oh, okay, good. We have a nice little cut scene here for a little relaxation. So it's business as usual, guys. What you gonna sell today on this beautiful morning? Hot dogs, fries, or pizza? Which one you think will make the most amount of money? And the winner is hot dogs. If you decided to sell hot dogs, the customers love hot dogs apparently by this corner here. All right. So you either add 150 or $3 to your bank account, depending on what you spent. Fries wasn't too bad. It's $50, but the pizza apparently was a bad choice. Probably the cheese was stale or something. Who knows? Right. Probably you didn't have good toppings. Probably you only had onions and garlic and tuna. Right. Let's move on. Oh no, this gets worse and worse. All right. So this one here is pretty straightforward. Sorry about this, guys. 1 second. Right. So this time we're going to add what? concentrated sulfuric acid. And these are the different types of ions, and this is what you expect to see or to observe. All right. And when you have either equations, the ionic equations that go with it, or you have an explanation of why it happens. All of these things here, you see the explanations, all of those things were created based on what I saw in past papers, right? So all of these are like past answers to previous questions. All right, so I don't think I need to go through all of them one by one. I think everyone is getting the hang of how to interpret the tables. But I know I'm going to have to give you a few minutes to do this one. So I would gladly give you 10 minutes. Take your time. And I know what some of you all are wondering. How are you going to remember all of this for exams? Right. All right, so this was concentrated sulfuric acid. If you're not finished the work, I can always scroll back at the end after class and you could fill in the missing pieces there. So this one here, this one particularly is one of the more popular ones in the exam. So to test for anions, they just always bring one of these, not always, but a lot of times. You're going to add something called silver nitrate, and after you add the silver nitrate, you're going to add aqueous ammonia. Now, look at these things, the three different colors you could get, right? You could either get white, cream, or pale yellow, all right? And of course, this one here, well, remember, you have to keep the order correct. You're going to add what first? The silver nitrate. And this here is everything you can expect to see when you add the silver nitrate. And after you add the silver nitrate, afterwards only, then you add the aqueous ammonia. The ammonia just either dissolve or not dissolve the precipitate. So the precipitate is either soluble. If it's bromine, Br minus, you get a precipitate that's slightly soluble. Okay. So once again, I don't think it has too much to explain in this. The table, in my opinion, is very self-explanatory. Take our 10 minutes again, and we will move on. The next one. Oh, at least we got a little bonus wrong here. All right. Choose a number between 1 and 20. 1 and 20 is included $50 extra. Going with the number 2. So if you guess 2, then you got it. $50 extra. Ah, yes. Sorry, but congrats to the winners. Congrats to the losers as well. All right, guys, let's move on. Another scary looking table. All right. So this is another test for anions. You're adding either barium nitrate or any type of chloride solution. But the point is, after you add any one of these, you're going to add any type of dilute acid. Now you gotta be careful here. This one here is sulfate, while the last one is sulfite. Okay, it's easy to mix up both of them, right? While this one is not as popular as the halogens, I've noticed in the past like 10 years of past papers, this particular table came like 2 to 3 times, right? So that's still a high frequency of comment, right? So once again, I'm not going to bore you with explaining the table because I think the table did a pretty good job of explaining it. Right, so the good news is I think we only have one more small table after this one. Made a small mistake here, right? I repeated the word twice by mistake, right? It is supposed to be white once. Fuck. Let's see this last table over here. All right, so this one is pretty short. This one is the test for nitrate ions, right? And well, once again, it's pretty self-explanatory, right? You're telling you exactly what you're adding. In case you don't know what copper turnings are just pieces of copper. There's a fancy word for it. And in both cases, they tell you what you expect to see. Okay. Right. When you're finished, take this down, right? You can leave, right? And of course, if you're having carnival, enjoy your carnival, be safe, right? And we have class this weekend as normal. All right, so